Hello, class. We're going to do the recorded lectures now for section 3.3, last section in chapter 3 in our stats class. And there's some information that is quite important in the grand schemes of stats. And this is the idea of measuring position. And the idea of position is where's the middle point, which we've talked about, but then where are all the other points? And where are they relative to respect to their fellow data sets that we have with our calculations. So here's the list of objectives in this section. We will definitely do z-scores, but we're going to come back to that when we talk about normal distribution. So in this lecture, I'm going to talk about calculation of quartiles and understanding the effects of outliers. And they're all kind of tied together. Then we'll talk about construction of a box plot, and then we'll talk about percentiles as well. And so with that, let's talk about, we'll skip that, and we will jump to the quartiles. So the idea of quartiles is we want to split, instead of the data in half, we're splitting it in quarters. It is Thursday, first day of football season, NFL, that I'm recording this lecture. And football split up into 4 quarters, right? And so basically we're going to do the same thing with the data. And the way that that works is the second quarter is the median. And we've already talked about calculation of the middle. And so with the median, 50% of the data is below the median, 50% of the data is above the median. And then the quartiles, it works the same way. So the first quartile means that there's 20% of the data below that. And the third quartile means that there's 25% of the data above that. And a better way to look at that is, I think, on a little graph that I've pulled out of a different book that I used to teach out of. And you can see kind of how everything's split up. So this second quartile here would be the median, and 50% below, 50% above. Here's the first quartile, and so that would be 25% of the data sits below that, and you can see the third quartile, 25% of the data sits above that. And so the question is, how do you calculate the other 2 points, the other 2 quartiles? Well, there is a, and I like, and I've been criticizing the book, I like their approach better than the last book I taught out of, and this is a very logical way to do it. And so the first thing you want to do is calculate the median. The median is right in the middle, and that is the quartile 2. And then define the first and the third quartiles. Basically, you take the total number, the data set, and you multiply it, for example, for the first quartile by 25% or 0.25. If that number, and they define it as L, is a whole number, you take that number and the next highest number, and you average those two together to get the quartile. If it's not a whole number, you just round up, and then that would be the value for that quartile. And this L is the position of the data set. It's not an actual data set value. And I think when we go through example, hopefully that, you know, what L means with regard to calculations will make more sense. So let's do that. So this is an example that I used last semester, and I think it's better than what the book has, so I'm going to walk through this example. But of course, the book has some examples as well. So this is data from 13 real estate prices of homes. And you could see that there's 13 values ranging from, I think the lowest 114,950, and the largest is 5.5 million, I think, is in this list here. And so let's find the three quartiles, the median or quartile 2, and then the first and the third quartile. So the way that I do all these is I put them in a spreadsheet. Unless there's only just a few of them, it's difficult to keep things in a nice organized fashion. Spreadsheets does a great job of that. And number 2, after I show you how to do this by hand, I will show you that the machine here will give you the 3 quartiles just by plugging the numbers in. So you'll see with using of the function values. So with regards to that, here's the list of home prices. And the first thing is to put them in order from lowest to highest. I've already done that. You do if you just type them in, you can do the sort function that we talked about. And I use the word index. And so this is the position of the data set. This is the smallest one, which is position 1. This is the second one, which is position 2. And you can see the biggest one, which is 5.5 million, is position 13. So we have 13 data points with regards to this data set. So what's the median? Well, we have an odd number, right? So you remember, you take 13 divided by 2, and you add a half to that, and what do we get? We get the number 7. And so the median would be this value right here, $488,800. And you can see that there are 6 data points above the median and 6 data points below. You see what I mean? 50% above, 50% below. So that looks like it's the right answer with regards to just looking at the numbers as well as the calculation. So what's the first quartile? Well, the first quartile is this L times equals 0.25 times N. So I'll do this on the whiteboard just to make sure that we have the equation. Sometimes it's harder to see the equation. So it'd be L equals 0.25 times N. And so if we do that, we have 0.25 and our N is 13. So here I get out my calculator and you get 3.25. And so when you go back to the slide here, just to refresh everybody's memory that I introduced, is that if it's a whole number, you take that number and add 1 to it, which is the 2 indexes, and you average them, but it's not a whole number, right? Which is nice, because then what you do is you round up. So our number was 3.25. So what do we do to round up? Round up would be position number 4. So 1, 2, 3, 4. So this would be position number 4. And so that would be, I'll call that quartile 1. And so this would be position number 4. And so let me unbold that one. So this is quartile 1. And you could see we have 3 above. And so that would be 25% of, or below, excuse me, smaller than 25% of the data below that. So how do we get the last quartile? Well, that would be, instead of multiplying N by, that'd be quartile 1. Instead of multiplying N by 0.25, we would multiply it by 0.75. And so we would have 0.75 times 13. And so we'll round up, that one's 4. So this would be 13 times 0.75. That would be 9.75. And so you'd round it up to 10, since again, it's not a whole number. So you go back to our spreadsheet. And position number 10 is right here. You can see the index, or you can call that position as well. So that would be third quartile. And so again, you can see there are 3 numbers above that, and that has to match with the first quartile, or obviously you did something wrong, right? We have 3 numbers below the first quartile, and we have 3 numbers above the first quartile. And then you say to yourself, well, this gets more than a little tedious, especially when the data set's really big. So again, as promised, I will show you how to do it using the functions. And so if you do that, there's actually a quartile function, and that's what I use for these calculations. And if you type in quartile, you would get this quartile here. And what's really nice about it, it gives you 5 outputs depending on what numbers you put and what's called the quartile. So to calculate the first quartile in the array, you put all the data. So you highlight the data. And in the quartile, when you click on that, it gives you a little key. So if you type in the number 0, it'll give you the smallest value in the data set, which would be position 1, right? Or index 1 in this case. Quartile 1, you type in the number 1. The median, you type in 2, which is quartile 2. Quartile 3 will give you the third quartile with the number 3. And if you want the maximum number, which would be the biggest number, you would type in 4. So here we'll start with quartile 1. So we'll type in 1. Hit OK, and you could see you get that same number. So this would be quartile 1. So again, oops, that's not what I wanted. You have to go to more functions, come back with quartile 2, and again, highlight the array, and the median would be quartile 2, which is right here. So I'll put Q2 in this case, which again is another abbreviation for median, and the last one would be quartile 3. So if I hit more functions, hit that, and you see you start to get good with the spreadsheet, and you can do things reasonably quickly. And quartile 3 is that as well. So you can see how the manual calculations and the calculations from the spreadsheet better match, right? Or we're doing something that's not right. So this is an example and a good way to do the calculations. And you'll see in this homework in this section, you'll have the opportunity to calculate the quartiles. So the next thing we want to talk about is this idea of an outlier. So given a list of data, sometimes you have an outlier, and depending on what types of analysis that you're doing, it might make sense to get rid of the outlier. And so we need a definition. And so the definition of an outlier is that it's a considerably larger or smaller value than the general data set that you have. And so one of the things is that we need a mathematical calculation to be able to do this. And how do we do that? Well, the statistics world has developed this figure of merit called interquartile range. And so this idea of interquartile range is the difference between the Q3 number, meaning quartile number 3 number, and the first quartile. So the idea is that, again, just think about this as a figure of merit. This is a figure of merit that will give you a number. And what were you going to do with that number? Well, what we're going to do with that number is that we are going to multiply it by 150%. And so we're going to take this IRQ number and multiply it by 150%. When you do that, you're going to get another figure of merit where it's 150% higher than the interquartile. And then what we're going to do is that we're going to take that number and subtract it from the first quartile. And if any data points are below that boundary, then it is an outlier on the lower side. And the upper boundary would be we add it to Q3. And if any number is above that value, you could say that it is an outlier at the high end. And so I'm going to do that same calculation using the data from the houses. Before we do that, let's take a look at the data in general. So the data in general is looking that our lowest value compared to the median is about 400,000 away. But you can see the highest value compared to the median is over 5 million away. So you could feel pretty confident that maybe this big one is definitely an outlier, and we'll prove that it is. Is the million, which is more than twice the median. Is that an outlier? Maybe. Is the low end an outlier? Probably not. But we're going to show you with the calculations that everything I've said fits the calculation. So the first thing you want to do is calculate the IR. I believe that's what it's called. Let me double check. IQR. I always get those letters mixed up. I knew that didn't look right. IQR. And so remember, the IQR is the third quartile, which is the 63.9 minus the first quartile, which is 38.7. So I'll let the spreadsheet do that calculation, and you can see we get 252,000, the difference between the two. So now the next thing you want to do is that calculation of 1.5 times IQR. And so basically, again, let the machine do the arithmetic. So 1.5 times IQR gives us 37,800, which is really close to the median, right? Which is 38,000 or 387,000 compared to 378,000. So again, just in summary, the first thing I did was calculate the IQR. And the second thing I did was take the IQR and multiply it by 1.5. So now let's look at the lower boundary. And so to do the lower boundary, I'll just call that LV for lower boundary. What you do is you take the median, right? So if you look here, whoops. I'm sorry, you take, I'm glad I re-looked at this. You take the Q1, the first quartile, and subtract that figure of merit from it. So that would be equals 38,700, and you subtract the figure of merit, and you see we get 9,000. So the question you ask yourself, if there's an outlier on the lower end, is there a number less than 9,000 price-wise? Well, no. So it looks like there's no outliers at the outliers at the low end. So then what do we do at the high end? I'll call that the high boundary. I'm not sure why those are in bold. So put them both in bold. So that one will be Q3. And then you add the figure of merit of 1.5 times IQR. And you can see we get 1 million and then 17,000, right? With regard to that. And so are there any values that are above that? Well, the 5.5 million is definitely above that. So let me put the outlier in blue color like that. So is 101,700 bigger or smaller than the next one? Well, this is a little bit bigger. So you see it's really close to being an outlier, but you can see that this data point is not. So we have one outlier, and just like we, hopefully our intuition knew that the 5.5 million was definitely an outlier with regards to these calculations. So let me do one more thing and let me calculate the mean. And one of the things with regards to an outlier is you think because we have one big outlier, the mean should be what? Bigger than the median. And so when you do that calculation, you do average, remember, and we just highlight all the numbers. And you could see that the mean, fix the format here real quick. Round to the nearest hundred or dollar. So you can see the mean is 865,000, which is quite a bit bigger than the median. And so usually when you talk about housing prices, one that is extreme on either side could really cause the median and the mean to be quite different. So that ends this recorded lecture on quartiles and outliers.